Dear committee, dear guests, it is my pleasure to introduce Viktória Vitai. She was born in 1993 in Hatvan, Hungary. She has a younger brother and an older sister. Viktória has started her studies in primary school in Hatvan and then followed by a bilingual class in secondary school in Gödöllő. From a young age, she developed a strong interest in nature, animals, in biology. Initially, she wanted to become a veterinarian. However, her passion shifted towards dentistry during secondary school. In 2012, Viktória enrolled in the Faculty of Dentistry at Semmelweis University and graduated in 2017. Throughout her undergraduate studies, she found herself particularly drawn to conservative dentistry and prosthodontics, especially to digital dentistry and aesthetic treatments. This interest led her to undertake her first research project as a TDK student at the Department of Prosthodontics during her 4th year. Her TDK research focused on shade selection methods and intraoral scanners. After graduation, Viktória continued her academic and professional development as a prosthodontic resident in the same department. She continued her research in digital dentistry as part of the Digital Dentistry Working Group. She is a founder and active member of the Prosthetic Department's validation project of intraoral scanners since 2018. In 2020, Viktória earned her prosthodontic specialty. In 2021, she began the Translational Medicine program to deepen her expertise. Her contributions to the field have been recognized with several awards, including the first place award for the best poster at the Hungarian Digital Dentistry Society's poster session, and 3rd place at the DDS Global Congress in Casablanca. Dr. Vitai is teaching both undergraduate and postgraduate dental students and digital dental designers. She specializes in digital dentistry, intraoral scanning, and chairside system. In addition, she co-authored the book chapter on chairside intraoral scanning systems in the prosthodontic textbook. Her commitment to enhancing educational materials extends to her current digital illustration course. She is aimed at making presentation and educational tools more accessible and engaging. Her hobbies: outside of her professional life, Viktória has a range of personal interests. She married in 2019 and recently moved to her new home with her husband. She enjoys horseback riding, reading, playing computer games, and participating in online self-improvement and presentation technique courses. She also explored a variety of activities such as fencing, dancing, running, swimming, jiu-jitsu, and painting. Viktória's diverse interests and professional accomplishments reflect her dedication to continuous learning, teaching, and advancing the field of digital dentistry.
Dear committee, dear audience, let me introduce my PhD topic, which is the prosthodontic application of intraoral scanning systems. My supervisor is Judit Borbély, and as a prosthodontic specialist, my vision is to make high-end digital prosthodontics accessible to every patient to the everyday digital workflow by integrating intraoral scanning systems seamlessly into the digital prosthodontic workflow. It is very important to translate the scientific results as soon as possible in the clinical practice. With the growing popularity of intraoral scanners, dentists face more and more problems connected to the digital impressioning techniques. That's why it is very important to evaluate and validate the intraoral scanning systems. The Digital Dentistry Working Group has been validating intraoral scanning systems since 2018, and we are expressing our results through a web page. During the Translational Medicine program, my specific goals contain the accuracy and shade matching of intraoral scanners. The first project is the evaluation of the accuracy of intraoral scanners for complete dark scanning, which is a systematic review and network meta-analysis. Some of the dental restoration materials can be already produced by CAD/CAM technology. And to use this kind of technology, we always need a 3-dimensional file, which is usually an STL file. We can do the digitalization indirectly with a laboratory scanner or directly with an intraoral scanner. We will find many different types of intraoral scanners in the market, and they are said to be accurate enough in the cases of solo restorations, but we found different results in the case of full arch accuracy. That's why our aim was to investigate the accuracy, the precision, and the trueness of complete arch intraoral scanning with the different intraoral scanning systems and compare them to reference STL files. And we wanted to provide dentists guidelines on choosing the right device for their complete arch scanning. That's why our hypothesis was that the intraoral scanning systems and the STL files generated with them are non-inferior to the reference STL files, and we assumed that the 95% of confidence interval of the accuracy of intraoral scanning systems is going to be within the clinical acceptable threshold of 120 micrometers. We used the PICO framework for the research framework. Here, the population was the complete arch with the maxilla and mandibles. The index test was intraoral scanners, about 26 different intraoral scanning systems. The reference standards were the reference STL files generated with laboratory scanners or industrial scanners, and the outcome was measured in the accuracy, in precision and trueness, in mean absolute deviation, and also root mean square values. During the systematic search, 5 different databases were used, and after the selection process, 114 original articles were eligible, and from that, 53 was involved in the statistical analysis. In the network meta-analysis, we differentiated 4 big different subgroups according to the clinical scenarios: dentate arch, partially edentulous arch with implants, edentulous arch, and also edentulous arch with implants. In all different subgroups, we generated the precision and the trueness group, and we expressed the data in mean absolute deviation and also in root mean square where possible. In all subgroups, we had generated network plots, liquid plots, and sucra plots, but I'm going to show you the forest plots results. So here we can see a forest plot for trueness for dentated arches in mean absolute deviation. In the forest plots, in the x-axis, we will see the mean difference relative to the control, where the 0 here is the control. And in the y-axis, we see the different intraoral scanning systems in ranking order from the bottom to the top with their performance. We use the 120 micron threshold for the clinically acceptable threshold, and in this subgroup, we can see that out of the 21 intraoral scanners, only 6 had no significant difference statistically from the reference, and the same 6 were within the clinically acceptable threshold. In the next subgroup, the trueness for edentulous arches, out of the 9 intraoral scanners, 4 had no statistically significant difference from the reference, and just 2 were within the clinically acceptable threshold. The trueness for edentulous arches with implants, out of the 17 intraoral scanning systems, 9 were within the 9 had no statistically significant difference from the reference, and 1 was within the clinical acceptable threshold. The trueness for partial edentulous arches with implants, here all intraoral scanners had statistically significant differences from the reference, and 4 were within the clinically acceptable threshold. The strength of this meta-analysis was that there was no other meta-analysis in this topic. We had a high number of studies that were involved, and with the network analysis, we can compare intraoral scanners indirectly and directly also, and it makes the ranking of intraoral scanners possible. Unfortunately, we don't have enough data about all intraoral scanners available in the market, and usually the articles use models and not real patients. Different reference scanners were used for the reference STL file generation, and we used the 120 micron value, which is not a gold standard, as we discussed. The conclusion of the first meta-analysis was that iOS systems are accurate enough for generating clinically acceptable complete arch digital impressions, But we have to notice that the complete arch accuracy will be different in different clinical scenarios. We can also say that the newer generation of iOS are not always the best and most accurate devices, but we can see a visible tendency for the increase in their accuracy. The second project was the color comparison between the intraoral scanner and spectrophotometer shade matching. About 65% of the dental restorations that need to be redone or replaced is due to the poor shade selection methods. Basically, dentists use the visual methods, which is a highly subjective method. The shade determination is done with the shade guides. And that's why new digital methods were introduced in the market, such as spectrophotometers, which are more objective methods. And they are said to be gold standards for the articles. Some of the intraoral scanners can also do shade selection, and if they are accurate enough in this shade selection, they can be two-in-one devices. Our aim here was to compare intraoral scanners' accuracy, the trueness and the repeatability to spectrophotometers in determining the two shade. Our hypothesis was that the shade selection with intraoral scanners is non-inferior to spectrophotometers regarding their trueness and precision. Here in the methodology, we used shade selection as population and shade selection with intraoral scanners as index tests. The reference standards were spectrophotometers, and the outcome was measured in accuracy, the trueness, and the precision with the match percentage. In the systematic search, we used the same 5 databases, and in the end, we found 21 eligible articles, and 10 were used for the statistical analysis. The results are shown in forest plots with trueness and precision in the subgroups, and also by subgrouping with the shade guide systems. Here we can see the trueness by Vita 3D master shade guide coding with 3 different intraoral scanners and 3 different spectrophotometers as reference. Here the trueness rate was 0.38, and unfortunately here and then in other subgroups also the heterogeneity was high. Clinically in this group, intraoral scanners were unacceptable for trueness. In the next subgroup, the trueness by Vita Classical, we had 2 different intraoral scanning systems and 3 different spectrophotometers. The trueness rate was 0.28, and here also intraoral scanners were unacceptable for the trueness part. The precision part in the Vita 3D master subgroup, we can divide this subgroup into the different measurement locations. So if we check the all measurement areas, so the neck, the middle, and also the incisal third, we found 0.33 repeatability rates. And if we just measure the central area, it's gonna be better, so it's 0.85. The pooled rate was 0.81, and here we can say that intraoral scanners' precision was acceptable. In the last subgroup, the precision by Vita Classical, we had the same repeatability rate, which was 0.81. The strength of this meta-analysis was that there were no other meta-analysis in the topic, just systematic reviews, and we adhered to the pre-registered protocol. In vivo articles were used for the statistical analysis, and we tried to reduce the high heterogeneity by using subgroups. The second meta-analysis conclusion was that there was significant difference in the accuracy of shade selection between intraoral scanners and spectrophotometers, and we found that the precision was high and comparable to spectrophotometers, but unfortunately the trueness made the shade matching with intraoral scanners unacceptable. In summary, in the first meta-analysis, we used intraoral scanners STL files and compared them to reference STL files, and we measured their accuracy, precision, and trueness. And in the results, we made 4 different subgroups, and we found that the accuracy of complete touch scanning by intraoral scanners differs based on the clinical scenarios. In the second meta-analysis, we compared intraoral scanners and spectrophotometers in shape determination, and we measured trueness and precision, and in the end we found that the low trueness made the accuracy of intraoral scanners unacceptable when we compared them to spectrophotometers. This dissertation contained 2 D1 journals with the cumulative impact factor of 8, and I have 6 other articles that are related to the topic, but they were not involved in the thesis. I have 2 ongoing studies, and one of them is a collaboration with the Vilnius University with Professor Utkunes, where we are going to measure the effect of different reference object strategies and intraoral scanners. It's a clinical study. My additional activities contain preparation of TDK students for TDK presentation, and one of my students is at UTDK, so unfortunately I cannot be there with her. But also I attended on conferences with the latest results of our studies. After the first meta-analysis was published, we were rethinking our validation study, and we redesigned it, and now we are already validated 38 intraoral scanners and published the results in this webpage. And with the second meta-analysis, I got 2 awards, the first best and the third best awards in poster sections. And I want to thank you, for all who helped me through this journey. I want to thank Dr. Borbély for helping me throughout my whole dentistry work. I want to thank you, Professor Herman, helping me also during the PhD studies. I want to thank Professor Varga also to being with us in every group meeting, and also to Professor Hegyi, because he was also there in the group meetings. And especially thanks to Anna Németh, because we worked together a lot with the meta-analysis. So I also want to thank the Department of Prosthodontics, the Digital Dentistry Working Group, my family, and my husband, all the help that I got. So thank you very much. And I want to thank with my own quote, which is life is a board game where the players must learn the rules by playing it. But it's not because we learn slowly, it's because the rules are always changing. So thank you very much.
Congratulations for your nice presentation, and I would like to ask the opponents to read their questions.
Oh, thank you very much for your interesting presentations, impressive studies. Because for the first study I have a question, because you make this intraoral scanner some 3D picture, and you take this accuracy limit 120 micrometers, which is actually 2D. How you come from 3D to 2D?
Yes, in the studies where they use the mean absolute deviation, it's not that accurate in this case, because sometimes they use the root mean square value as well. It is rather about the 3-dimensional differences than the mean absolute deviation, so it's like a pooled surface deviation in the case of mean absolute deviation. I think it's important to check not just mean absolute deviation, but also root mean square results and other metrics as well, because yes, it's not that accurate in this case.
And when you showed first 2 meta-analyses, forest plot, it was always 1 or 2 studies which were over this 120 micrometers limit. Do you have any explanation why in these studies they have so large deviation?
In the first meta-analysis?
In the first, yes. In the first meta-analysis, it was 2 forest plots when you have this red line and some parts were
very
on
high.
the right side. And
Yes.
do you know any explanation what was with this study? What happens with this study?
Here, on the forest plots, we can see the different intraoral scanning systems, and there were some outliers.
Yes.
These were usually older generation of intraoral scanners, and they were not recommended for full arch scanning, but they were also tested for complete arches. So, for example, BlueCam, it is a very old version of the CEREC system, and it was not recommended for full arch cases, but still they published results on the complete arch. So mainly the outliers were not really recommended for full arch cases. They were recommended for quadrant scanning, and they were usually older versions of the devices. Thank you.
Okay, thank you for your presentation. What would you say that maybe we are missing the connection between the precisement or the accuracy that you measured and the patient perspective? Are there maybe some different thresholds in different clinical scenarios for the precisement that we needed in prosthetic rehabilitation?
So you mean about 120 microns should be changed in different clinical scenarios?
Yeah. If there is a completely edentulous patient and you are planning to do some removable prosthesis, or if you want just to change one crown or restore one crown.
Yes, when we were discussing about methodology and also trying to find a nice threshold to translate the results into the clinical practice, it was very hard. As also Anna said, it's not a gold standard. For edentulous patients, if we just want to do a complete denture, for example, we don't need that high precision. In this case, I found articles that said that because of the compressibility of the mucosa, can be around 2000 and 2050 micrometers, we can be more tolerable for the dentures. For local fit, this is different. Local fit should be more accurate than the complete arch fitting. So in this case, also they use 30 and 50 microns and not that big thresholds as 120 micron. Also, it can be interesting in orthodontic usage. It is also a question if we just want to use an aligner, for example, that we want the aligner to fit on the whole arch. So it can be different as well. So yes, this should be a very interesting topic to differentiate the thresholds according to what we want to do.
And you also said in the second study that intraoral scanners didn't reach the level of precisement of the spectrophotometer. But what about the patient perspective? So if we ask the patient, does he notice the difference in a tooth shade? It's not important, is it 100% precise, but is it notable to the eye of the patient if we miss it a little bit, if there was some imprecisement?
Yes, you're very right about this. What would be very nice in this case is to use the delta E values, because delta E values are used in color sciences to evaluate the difference between two color measurements. There were some studies that used the delta E values, but the problem is that the intraoral scanners cannot show us the delta, the LAB values. So the LAB values are used for the delta E results, and because they cannot produce the LAB values, they unfortunately cannot provide the actual numbers, and that's why they used converting tables to convert the numbers to the shade guide system coding. And if we don't use the same coding system, then there will be differences between the results, and this was the biggest problem also in the previous systematic reviews, that everybody wanted to use the delta E value, so we can say that if the patient can see the difference or not, or I can accept even if I see the difference. But there were not enough data about this, and they were not comparable due to the converting charts. Because spectrophotometers can give us the numbers, but intraoral scanners cannot.
Is it the difference between the chroma value that cannot be determined quite well, or is it the lightness then that intraoral scanner cannot catch? It can catch probably the chroma, but not the lightness well.
I found studies that try to evaluate which factor was not easily detectable for intraoral scanners, but I don't remember what they thought, because in the different studies they found different results. So I don't know what was the real final result for them. But this can be very interesting. What I think, which was visible, for example, in the precision group, where we can differentiate the neck part, the middle part, and the incisor part, that intraoral scanners were more precise when we just measure the middle part. And I think, but I don't have a study about this, that if we go for the incisor third, the translucency is higher than in the middle and in the neck. And maybe if the scanner, just like an optical scanner, sees through the transparent enamel, then maybe it will detect the darkness of the oral cavity and not the true shade. And in this case, what I see on the screen, that I see a grayish edge on the incisor third. And even if I 3D print a model like this, I will see it in the 3D printed colorized model, that all the edges are gray. But I don't know, I didn't find a right study for that.
Okay, and will intraoral scanners ever reach the level of the spectrophotometer in determining the shade of the teeth? What do you think?
I don't know. But I think that maybe if there is an error, that is a type of error that is again and again the same problem. So, for example, if only the dark background is the problem, maybe an algorithm can help us to compensate what the translucency is causes. But even with spectrophotometer studies, they use natural backgrounds of black or white in laboratory surroundings. So I don't know how they can make this better, but if there is an algorithm, maybe it can help. But for now, we don't have evidence. So this is what I can say now to dentists, that if they want to have a good sheet selection, just don't think that the new device is like a shiny device that will solve every problem. So I would just say now that we don't have evidence. Maybe later on it can be better. Professor Herman is always giving us a very nice example that intraoral scanners are very similar to mobile phones, because first we use them for calling and maybe writing messages. Like here, intraoral scanners were just used for impressioning, and now they have many additional features like the sheet determination, maybe caries detection, and so on. So also we know that mobile phones are now used for other purposes. We are doing pictures and videos and not just calling and messaging. So hopefully there will be an improvement.
Yeah, bright future.
Hopefully, yes. Thank you.
Thank you, Viktória. I just wanted to come back to this precision and trueness, which we already discussed by the different jury members and also in the presentation of Anna. And for both of your studies, the reviews, I recall that it was mostly in vitro work, right? Or are they clinical? I know that you are now busy with Professor Utkonas from Vilnius to do clinical study, but both study 1 and study 2 are all the included studies in vitro studies?
In the first meta-analysis, they mainly used models, so they were in vitro studies. But for the second one, in the statistical analysis, we just used in vivo. Not in vitro, just in vivo, because it was said that spectrophotometers were not very good at in vitro circumstances. For example, the SpectroShade, easy shade spectrophotometer, and that's why we collected in vivo articles for that purpose.
Yeah, but indeed, then still there can be a lot of variables with the lightening conditions, like you mentioned. Exactly. Coming back then to the first one, the in vitro one, you mentioned it already that you are busy with this clinical part. We have done that in the past as well. Do you expect a big difference in accuracy there? Because you were talking about a different accuracy level compared to the in vitro, which is very close to what these commercial companies tell what is there. What do you expect from the clinic?
About the
about the trueness, about the precision, about all the factors.
Yes, in vivo circumstances, I think all these results gonna be worse than what we got in vitro, because models are more easily scanned.
Exactly.
Yes. Also, we have experience on that, to be honest, because in our validation system, we are doing model scanning and also doing in vivo scanning to test the patient's satisfaction, and also to test if the operator is okay with the scanner, how I can handle it. And also we measure the time, how much time do I need to scan a whole arch on the upper jaw and the lower jaw, and also how much time do I need to scan a model. And we see big differences in some cases, even in the time, and it's not about accuracy now, it's about the time, so there will be differences in time, but I think also in the accuracy, because we have saliva, also humidity, blood, gingiva, and so on in vivo circumstances.
A good reference, but unfortunately I don't know where it is, but the first system there, this lava COS system, which is from 3M from years ago, there was no water, no saliva, you had to spray with titanium oxide, and that was actually much more accurate than all the systems that are now on the market. So maybe if you find some system there as a kind of clinical reference, but you spent much more time, of course, and you needed to be trained very well. But okay, I think I have maybe one last part for this this shade analysis. You have there different products that you showed in the, you have different types of commercial color shade. You use the generic name, but in the studies, not everyone uses the same spectrophotometer. Did you look in the literature to the difference in accuracy to the commercial systems that you use as a kind of clinical reference for study 2?
Yes, thank you very much. Yes, I tried to find references that were comparing those systems. So, for example, SpectroShade and EasyShade spectrophotometers. And also, I found different results, but most articles describe them as similar. So even with the Vita EasyShade spectrophotometers, they have different generations, like EasyShade 5 or Advanced. So with the SpectroShade, I think it was said to be the most reliable one, the SpectroShade. Thank you.
Encourage the audience to give a question. Do we have any prize or present for the student task? Not the statistics.
Okay, so thank you very much for this very good talk. Here also the same compliment, I should say, that you presented quite well the statistical things. And just a small question in my mind is that there is any difference between the scanners in terms of how easy to use to learn to use. Or, for example, I cannot open my mouse too large. It's always a problem. And the question is whether it is easy to make wrong scanning due to these thing, for example. So how to easy to use and how easy to make it wrong, basically. This is my question.
Thank you very much. About the operator experiences, we find and also published articles. The handling of the intraoral scanner can be different for the different operators. For example, the size of the handpiece, if it is bigger, smaller, the tip of the scanner. We also measure those in our validation study. About the tip of the scanner, first we saw that the smallest is the better. But we also looked the practical point. And here, if we have a bigger tip, the scanning area is going to be bigger. So we can make the scanning faster. If we have a smaller tip, we should take more pictures and we need more stitching. And in this case, it's going to be time consuming and maybe we can have some accuracy problems. So I think it's important to have more different tips. For example, smaller, medium, and bigger tips. And in this case, I can change according to the patient's mouth opening, for example. So this can be a good option. Also about the handling, the weight of the handpiece can be an important factor because if I have to scan a lot, for example, I just doing intraoral scanning throughout the day, if the handpiece is very heavy, it's not going to be comfortable for me later on. Here, for example, Cerex Prime Scan was the biggest handpiece what we tried. But we know why it is so heavy. It's because it has a data acquisition inside the scanner itself. So it's not that comfortable, but the data acquisition is going to be faster and can be accurate.
Thank you very much. I'm glad that you work on this issue as well. So it's quite good. Thank you very much.
Thank you.
And while you mentioned a lot of things, it came to mind, what about combining the scanning from two scanners, for example? So somehow with a mathematical algorithm, there are two types of scanners and try to make a third one from the two scanning results, basically. So there is also such a direction?
Do you mean that we can generate one arch from different scanners and then merge them?
Yes, a better one, a third better one.
I don't think that's gonna be a practical thing. I don't know, they didn't want to search about this because I don't think that it has practical applicability.
Thank you very much.
But thank you.
One more question? Sure. Maybe if there is no more scientific question, may I have a kind of provocative but honest question that what we see here in the last year that Chinese manufacturer just vanish the market and the classical or conventional Western European manufacturer, including US, 3Shape, Planmeca, Cerex system, others, they have double price or sometimes 3 times more price. And this Chinese scanner has a very good operator experience, and including the price. And as far as I know, the clinicians who are never read any research, what do you expect? That do they vanish the market completely and they don't care about the accuracy? And do you know anything about the accuracy? Because there are almost no published article about these scanners in terms of accuracy, for example.
I think it's a kind of marketing problem or much more political, but it can cause big problems, of course, for dentists. When we first invited the manufacturers to do the validation study, we wanted to also get feedback from them and also give feedback to them about the scanners, and we wanted them to take more responsibility about their scanners and about their accuracy and other parameters, of course. yes, we see that there are many intraoral scanners in the market year by year, and we don't know those manufacturers. And it can be, of course, a big problem, because we don't know if we need the support, if we have any problems about the scanning, then who should we call? So in our validation study, it was a very important point also to check the support, if I can rely on them, if I have any problems, because it is, I think, sometimes more important than just the price. So I think this can be a very important factor if you want to buy a device, not just the accuracy, not just the handling, but also the support. Thank you.
Thank you very much. If there is no more question, then I thank you for your answers. Thank you for your lecture, and we are going for discussions, and we will be coming back.
Thank you.
I would like to announce the final grade in percentage is 92%, so it is equal to summa cum laude. Congratulations for your work, for your hard work, for the 6,000, 70,000 articles and so on. But congratulations from the name of the committee. I'm officially closing this.